Assalamualaikum. We are from program CS110 Group 2C. Let's choose apply maximum and minimum topic to present in this video. Our team members consist of firstly YAZID ZAQWAN HAKIM bin YUSOP ZAKI, which is me. Secondly, MUHAMAD ZULKARNAIN bin SAMSUDIN. Thirdly, Amirul Fariz bin ZAHARI. And lastly, MUAZ bin MAHADI.
So we begin with introduction. Calculus application issues frequently involve function whose maximum or minimum values you want to find. The domain from which you must operate will be determined by the limitations specified or implied for such functions. What is actually applied maximum and minimum? The highest point on the graph of a function is referred to as the function's maximum point. This point also has the largest y values of any point on the graph. The lowest point on the graph of a function is known as the minimum point of that function. This point also has the smallest y value of any point on the graph. The process of determining the highest or lowest possible values is referred to as optimization. So, why we use apply maximum and minimum? Basically, for instance, if we want to install a glass window in our room, we need to determine the largest possible surface area of the window's pane so that it will fit within the window's frame. In order to resolve issues of this nature, we make use of applied maximum and minimum. So next, how to use the formula? To start, you must first understand the problem by drawing a diagram and labeling the numbers that are important to it. Second step is find the equation for the quantities whose maximum or minimum should be determined. As you can see below, this is the example of a formula that we can use in applied maximum and minimum.
Next, we go to problem statement. For the question given, figure below shows a right cylinder closed at both ends, has a radius S and height Y. So we can see that S is the radius of this cylinder and Y is the height of this cylinder. Next, we can proceed to the question A. If the surface area of this cylinder is 150 pi cm square, write Y in terms of S. For this question, we need to find Y in terms of S, which is have given the surface area is 150 pi cm square. So next, we go to question B. Prove that the volume of this cylinder is V equal to 75 pi S minus X cube. So in this question, we need to prove that this volume of this cylinder is 75 pi S minus X cube. For the last question, C, find the value of S such that the volume of this cylinder is maximum. In this question, we need to find the value of S, which is a radius of this cylinder.
Next is problem solution. Firstly, to solve question A, first step, we must know and write cylinder area formula, which is 2 pi x square plus 2 pi xy. Then equal the formula to the cylinder area that already given by the question, which is 150 pi. And then move 2 pi x square to the right because we want to find y in terms of x. Next, move 2 pi x to the right and it will become 150 pi minus 2 pi x square divide 2 pi x. And next step, separate it if we want to simplify it easily. After we simplify, it will become 75 over x minus x square over x. And lastly, write a real answer, which is 75 minus x square over x. Next, to solve question B, first step, we must know and write the cylinder volume formula, which is pi x square y. And then, the next step is to replace the y that we already got from question A into the formula. It will then become V, which is volume, equal to pi x square times 75 minus x square over x. Then multiply pi x square by 75 and multiply pi x square by minus x square and then over it to x. It will become a volume equal to 75 pi x square minus pi x to the power of 4 over x. Last step, simplify the equation by cutting or slashing x. And then it will become volume equal to 75 pi x minus pi x to the power of 3, which is the same as the question 1 to prove. Lastly, to solve question C, first step, write again the volume formula that we already got from question B, which is V equal to 75 pi x minus pi x to the power of 3. Next step, do differentiate the equation, and after that it will become dv over dx equal to 75 pi minus 3 pi x square. And then write dv over dx equal to 0. After that, dv over dx, which is 75 pi minus 3 pi x square, will equal to 0. And then solve it by moving 3 pi x square to the right, and it will become 3 pi x square equal to 75 pi. Next step, move 3 pi to the right, and it will become 75 pi over 3 pi because we just want the only variable x on the left side. After that, calculate 75 pi over 3 using a calculator, and then the answer is 25. Next, to get the value of x, square root of 25, and then it will become x equal to 5 cm. To prove it is maximum, we must do the second derivative for the volume equation. After differentiate it for the second time, it will become negative 6 pi x. And then when x is equal to 5, replace 5 into the negative 6 pi x, and it will become negative 6 pi multiplied by 5. Then calculate it using a calculator, and the answer is negative 94.25, which is it is less than 0. So because it is less than 0, x, which is 5 cm, is the maximum value.
Conclusion for our presentation. All in all, for question A, we need to know the cylinder area formula, and then we can find the value. Then, for question B, we must know the cylinder volume formula, so we can replace the y value that we calculated earlier with the volume formula. Finally, for question C, we must find the derivative, set it to 0, and then find the value of x. In addition, to prove it is a maximum or not, we must perform a second derivative test, and if the second derivative lower than 0, the value is maximum. Reference. This is our reference. That's all from us. Thank you.